Hello students, welcome to the third session of exercise 2A, chapter 2, work, power, energy, solving numericals. Without any delay, let us go to the lessons. Look at the screen. Read the question given on the screen. A boy weighing 350 Newton. So what is the weight? Weight is nothing but it is the force given over there. Force is equal to 350 Newton. Climbing up 30 steps each of 20 centimeter high in 1 minute. The time is given is 1 minute. That is equal to 60 seconds. You know it. Now what is the distance covered by the body? The distance covered by the body or the boy is equal to 30 steps of 20 centimeter height. 20 centimeter, that is equal to 600 centimeter, that is equal to 6 meter. Alright, so distance covered by the boy is 6 meter. So calculate the work done. So work done, you know the formula, force into displacement. The force is given there. What is force? 350 Newton multiplied by the displacement is 6. So 350 multiplied by 6, you are getting it as 2100 joule. Joule is the SI unit of work or the energy. So that's the first part is over. Moving on to the second part. Second part, we have to calculate the power spent by the boy in going up or in climbing up the stairs. So power, you know the formula, rate of doing work, W by T. Work we have calculated already over here. Just to place the value of work, that is 2100 joule divided by what is the value of time given there, that is 1 minute, that is equal to 60 seconds. Cancels. So 210 divided by 6, how much you are getting it as? 35. Divide and see, we are getting the answer as 35 watt. Okay, so the power spent by the boy is 35 watt. Clear? Steps are clear to you? Okay. Now let us solve question number 13. Read the question from the screen. It takes 20 seconds for a person A of mass 50 kg to climb up the stairs, while another person B of the same mass does the same in 15 seconds. Compare the work done. Second, power developed by the person A and B. So in this context, we can see the work done by the both person will be same. Why it will be same? Because work done is not dependent on time. As work is independent on time, I can write work done by the person A divided by work done by the person B is equal to 1 divided by 1. That's equal to 1:1. So what is the reason? Work done, I can write work done is independent on time. Clear? So work done is independent on time, so work done remains same, that is 1:1. So what is the second part? Power developed by the person A and B. So here the time taken by the person A is 15 seconds. Time taken by the person B to do the same amount of work, it is 20 seconds. Clear? So you know power is depending on time. Power depends on time. How it depends? Power is inversely proportional to time. Clear? But remember, work done is independent on time. Power is inversely proportional to time. So I can write power developed by the person A to power developed by the person B. Directly you can write the time given 15 divided by 20. Because both persons are of the same mass. Clear? So I can write 3/4. So the power developed by person A to power developed by person B, they are related in the ratio of 3:4. So this is the answer. So the power developed by the person A and B are different because both take different time to do the same amount of work. Clear? Steps are clear? Okay. Now moving on to question number 14. Look at the screen, read the question. A boy of weight 14 kilogram force climbs up the 15 step, each of 15 centimeter high in 10 seconds, and a girl of weight 20 kilogram force does the same in 5 seconds. Compare the work done by the boy and girl, and we have to compare the power developed by both of them. The value of G is 10 Newton per kilogram. Okay, so first we will calculate the work done by the boy. I write WB, force into displacement. Since the boy is going up, he is doing work done against the force of gravity, so I can force will be replaced by mg, s will be replaced by h. Clear? So we are getting the value as given, it is m is given there, 40 into value of g, 10 into what is the height, 15 steps of 15 centimeter, 15 multiplied by 15. Clear? So this is the work done by the boy. So what is the work done by the girl? Is equal to force into displacement, same, mgh, since the work is being done against the force of gravity. So work done is equal to the potential energy stored. So what is the mass of the girl given there? That is 20 into 10 into the height remains same, 15 into 15. Clear? So let us take the ratio of work done by the boy and the work done by the girl is equal to 40 into 10 into 15 into 15 divided by 20 into 10 into 15 into 15. So everything get cancelled out. So 40 divided by 20, we are getting it as 2 by 1. So I can write the ratio work done by the boy to the ratio of work done by the girl. It is in the ratio of 2:1. Is it clear? Steps are clear. So that first part is over. The second part, you have to compare the power developed by both of them. So I can write power developed by the boy, PB, is equal to work done by the boy upon time. So work done we have already calculated here. That is 40 into 10 into 15 into 15 divided by time taken by the boy to do the same piece of work is 10 seconds. So write 10 here. Okay. So I am getting it as 40 multiplied by 15 into 50, I am getting it as 9,000 joule. The same way work done by the girl is equal to Wg divided by time. So what is the work done by the girl? So we have calculated here 20 into 10 into 15 into 15 divided by what's the value of time? Time taken by the girl to do the same amount of work is 5 seconds. So 4 tens are 40 multiplied by 15 into 15. We are getting it as 9,000 joule. So let us take out the ratio. Work done, power developed by the boy to that of power developed by girl is equal to 9,000 divided by 9,000. So the ratio of power developed by the boy to the power developed by the girl is in the ratio of 1:1. So the power developed by them remains same here, 1:1. Steps are clear? Okay. Now moving on to question number 15. Look at the screen, read the question very thoroughly. A man raises a box of mass 50 kg to a height of 2 meters in 20 seconds, while another man raises the same box to the same height in 50 seconds. Compare the work done and the power developed by them. This is the first part. So the mass remains same and the height remains same. Obviously work will remain same. Okay, because work is independent upon time. Work done is independent upon time there. So I can write work done in raising a 50 kg of mass to a height of 2 meters against the force of gravity is work done is equal to mgh. You know the formula. Alright. Hence both men will do the same amount of work here. Right. So I can take the ratio work done by the man A is equal to divided by work done by the man B, that is mgh upon mgh. Correct? So we are getting it as mass is 50, mass remains same, value of G 10, and the height remains same, that is 2 meters divided by 50 into 10 into 2. So we are getting it as 1:1 cancelled out. So we are getting the work done by both men A and B in the same ratio, 1:1. So work done doesn't depend on the time there. the mass and the height remain same, work done will be in the same ratio. So we have compared work 1:1. So we have to compare the power. Okay, the first man takes 2 minutes. How much? Yes, 20 seconds to raise 50 kilogram mass, and the second man B takes 50 seconds to raise 50 kilogram mass. So the power developed by man A, PA, is equal to work done by the man A upon time taken. So what is the work done by the man A? That is 50 into 10 into 2 upon what is time taken? What is the time given? TA is equal to 20. Alright, 20 seconds. Correct? Yes. So write 20 here. So 2 cancel. I am getting it as power developed by the man A is 50 watt. Alright? Okay. So what is the power developed by man B? That is work done by the man B upon time taken. Clear? So work done by the man B is already given there, 50 into 10 into 2 divided by time taken by the man B to do the same piece of work in 50 seconds. Okay, so write it 50. So we are getting it as 20 watt. Okay, so we have calculated the power developed by the man A and power developed by the man B. Now take the ratio, PA ratio PB is equal to 50 divided by 20. So we are getting it as 5:2. So that is the ratio of the power developed by man A to man B, 5:2. Clear? Yes. Now we have to calculate the work done. Work done, second part, work done by man A is equal to, we have already calculated, mgh is equal to 50 into 10 into 2, that we are getting it as 500, that is 1000 joule. Correct? Yes. So what is the work done by power developed by the man, each man, that we have already calculated it as 20 watt and 50 watt, and we have taken the ratio. The ratio of the power 5:2, power developed by each man already we have calculated 50 watt and 20 watt. So anything is left? So we have calculated the work done by work done by the man B, that also mgh, it is obviously clear, that is equal to 50 into 10 into 2, that is equal to 1000 joule. Obviously, since the work done is in the same ratio, so it will be equal. Is it clear? Steps are clear to you? Read the question thoroughly and solve it. Moving on to the last question, question number 16. Read the question carefully. A boy takes 3 minutes to lift a 20 liter of water of bucket from a 20 meter deep well, while his father does it in 2 minutes. Compare the work and the power. Second, how much work each of them does. So similar type of questions we have already solved. So you know that a boy takes 3 minutes to lift it. Time taken by the boy is 3 minutes. That is equal to 3 into 60, 180 seconds. Alright. Time taken by his father, TF, I write it as TF, 2 minutes. Alright. That's equal to 120 seconds. The volume of the water is 20 liter. Volume is 20 liter. You know, when volume is 20 liter, the density of the water being 1000 kilogram per meter cube, volume is equal to, mass is equal to, we can write mass is equal to volume into density. So volume is 20 into 10 to the power minus 3 meter cube into 1000 kilogram per meter cube. So that's the density. So this cancelled, I am getting mass is equal to 20 kg. So 20 liter is approximately equal to 20 kilogram of water. Clear? Yes. So we have to compare the work done. So work done by father to work done by the boy. We have to calculate here. So you know, as long as the mass remains same and the height is also given there, how much? 20 meter. So work done remains same, that is mgh upon mgh, that's equal to mass is 20 G is 9.8, height remains same, 20 divided by again 20 into 9.8 into 20. So everything cancel out, we get it as 1:1. So as long as the mass of the water and the height to which the water is to be lifted remains same, the work done, ratio of work done remains same here. Now we have to calculate the power developed by father and power developed by boy. You know, the time taken by boy and father is different here, and the power is inversely proportional to time. So I can directly write the power developed by father and the power developed by the boy is in the ratio of 2. Time taken by the father 2 minutes divided by time taken by the boy, that is 3. So I can write 2:3 directly, because since power is inversely proportional to time taken. Clear? So the power developed by the father and power developed by the boy is in the ratio of 2:3. Correct? Okay. Now what you have to do? Work done by each. So we have to calculate the second part, work done by father, WF, that is equal to mgh. Okay, work is done against the force of gravity. So you use the formula mgh. M is given there, 20 kilogram. G is 9.8 into, what is the height? 20. So solve it. 20 into 20 multiplied by 9.8. How much you are getting? That you are getting a 3920 joule. That is equal to 3.92 kilojoule divided by 1000. So obviously both the work done remains same. So I can write work done by the boy is also mgh. You will get, since the ratio is 1:1, 3.92 kilojoule. Correct? Yes. So we have calculated the work done. Both of them do the same amount of work. Clear? So learn the formula, practice the formulas by applying it in numericals. Practice different varieties of numericals so that you can be an expert in solving numericals. So that's all for today. Have a nice day. Thank you very much.